Hello everybody, thank you for joining our webinar. Before we start, I would like everybody to keep yourself muted during this session. Just keep your microphone, your line. For communication, please use private chat, WebEx chat. Address your questions directly to me, who's host or presenter. Our webinar will consist of a few parts. In the first part, I will brief presentation about ZAPTEST. Second part will be dedicated to our topic. And at the end, I will allocate 15 minutes for a Q&A session. As the first part of the webinar, I will make a brief introduction about who we are as the company, and we'll talk about main ZAPTEST offerings. We have been in the business over 20 years. We position ourselves as the full-stack cross-platform testing solution. With ZAPTEST, you can automate applications on mobile, Windows, Mac, Linux platforms, and we fully support agile development methodology. We're based in Atlanta, Georgia. Our core technology is one script, which allows us to script test procedure once and execute it anywhere. We are test optimization leaders, which means that with ZAPTEST you can automate any application, can meet any development schedule, and you can accommodate any skill set of your team members. As a full-stack technology, we provide end-user test automation in a cross-platform fashion. This means that you can create your test script on one platform or environment and play it as is anywhere else. Besides that, for other technologies which are not commonly offered in the industry. For example, with ZAPTEST, you can auto-generate test documentation. This may offset a lot of man-hours of writing documentation manually. ZAPTEST can do it for you. We also have technology for parallel device execution. The MRun ensures just-in-time regression testing. With MRun, you can connect to multiple devices with different platforms or different browsers and execute same tests simultaneously on all of them. We also have device host management private cloud system, which we provide to ZAPTEST users. The farm offers test device management capability and provides universal access to the devices across organization for the purpose of mobile application deployment, manual testing, automated testing, and parallel test execution. With ZAPTEST today, you can do API or web services testing. You can use the tool for an API standalone test automation or for building combined API and UI testing framework. Recently, we released the load component, which enables our users to do API performance testing as continuation of quality assurance process. As you can see today, ZAPTEST can be used as a one-stop solution for majority of quality assurance needs. Okay, let's move on to the main topic of our webinar, object recognition in ZAPTEST. ZAPTEST uses visual-based object recognition principle, which we describe as ZOE, ZAP Object Recognition Engine, and it's based on three main principles, three main aspects. OCR, optical character recognition, image recognition, the edge or border detection. When we make a scan of the GUI, we can see how all three work. I'm going to scan the login page of our website. To scan, I just need to press the Scan GUI button on the ZAPTEST, and inside the application under test, which is a browser window in the case. Once the scanning is complete, you will see a range of objects that ZAPTEST automatically adds to your object repository. For any text or image that ZAPTEST identifies on the GUI, create separate object. If you look closer to the object ZAPTEST adds, you will see that some objects OCR based, usually depicted by green color. Some objects are image based, usually depicted by color. Some objects appear as relative objects. For example, you can see arrow pointing from my username to the edit field, from password to the field, indicating that these objects are relative. Relationship also can be viewed repository through object hierarchy. So this is how all three main principles work. For each object, ZAPTEST provides a set of properties. When you get to an object, you can see object properties listed in the object properties panel. Today we will talk about all of them. But before I do this, I'll show you what we can do with the scanning process itself. If I expand my scanning button, you can see that we have different scan modes. We can use regular scan application mode, we can scan multi-line, we can scan blocks, we can see what scan GUI properties have. We can scan from images, we can scan using template, and we can scan image using template. What I just demonstrated is the very regular basic scan. So ZAPTEST identifies objects as standalone, text, images, and relative objects. If for any reason you want to turn off auto-anchoring when ZAPTEST defines relative objects automatically, you can do this through the scan GUI configuration. When I uncheck this checkbox, ZAPTEST will no longer do automatic auto-anchoring. After the scan, if you need to change relationship between objects, you can do this easily through the GUI map context menu of the object by selecting set parent object, then clicking another object on the GUI. So let's talk about object types that ZAPTEST offers. After the scan, you will always see an object type, which is called object. Means that this is a standard ZAPTEST object. This can be OCR-based object, it can be image-based object, relative object, coordinate-based object, so all these belong to the same object class. If I expand this list, I can see other object types: area, list, swiper. I will talk about other object types during the session. But for now, let's get one step back and see what we can get with different scan. What happens if we scan multi-line? ZAPTEST will try to identify text with multiple lines, like paragraphs. So I scanned the same login page using multi-line mode, and now you can see that ZAPTEST adds objects like this, where we have text from two lines combined and as a single object. And this is another example. So this is where you can use multi-line scan mode when you need to add objects automatically that multiple line text position, like paragraphs. Another scan mode called scan blocks. What happens when we scan with this mode? ZAPTEST will try to identify visible blocks on the page, test objects. I see that I got the object which covers the entire area of the GUI. Delete this. Okay, behind that I have object for this block, this block, this block, and a few other blocks beneath them. So ZAPTEST identifies blocks by borders. This is where we have edge detection or border detection principle in effect. And if I look in the text property of the subject, I can see that all the text that we have inside the block of the text property. Now we will talk about different object properties. Object properties will ZAPTEST will provide different set of properties for different object types. And most of them you will see for OCR object types. Here I selected ZAPTEST object on my first view, first scan. And the object properties include text, precision, appearance, text color, gamma, character, scalability, and a few others. So let me talk about all of them. I already mentioned the type property, which defines the object type. So this is the standard object, has object value here. Text, it's an important property for OCR type object because it includes text that ZAPTEST will use to identify the object at runtime. Any of the properties including text can be dynamically modified or parameterized. If I click this button, I can define a parameter which will hold the text value for this object. Next property, precision. Precision sets for ZAPTEST how precisely it should look for the text of the object. Also, precision applies to image object. Let me show you one example here. Let's say if I select this object, remember me, see that during the scan ZAPTEST gets this text for this object. If I use a precision tool, the GUI map, this object, it shows me that it finds it with 100% precision. So ZAPTEST uses the text and identifies the checkbox as a few characters like this. All right, now what happens if I don't want to use these characters in the object definitions? So now I will precision tool again. ZAPTEST shows that it finds the object with slightly less precision, 74%. Okay, what happens if I change this text further? Let's change me to you. Remember, if I run the precision tool, ZAPTEST still finds the object, but it's precision. So this is basically how precision works. Why ZAPTEST finds my object when I change its text? Because I have precision level set to medium. In ZAPTEST we have predefined precision levels, low, medium, high, and custom. Default is medium, so ZAPTEST using the medium precision level tolerate changes in the object text as you see in my example. If I need to use exact text, I can increase precision level to high, which sets it to 85%. So with this precision level, if I run precision tool for this object, ZAPTEST will tell me it is no longer found. This is because my precision level is too high for this text to be found on the... Change it back to the... Can run it one more time. ZAPTEST finds it with 85%. This is exactly what precision. Right. Next property I want to talk about is appearance. For this object, appearance says best match, but if I to the object, ZAPTEST appearance tells me that finds first object by its order. This is because we have two objects with a login text. Login link inside the login button. Same text. If I click on a text inside the login button, I can see that appearance shows number 2. So this is the order of appearance. ZAPTEST assigns appearance order based on scanning direction, and it always scans from right and from top to bottom. For this object, which is part of the login button, I show you a quick example. First of all, I want to set its precision to high. Let's confirm that ZAPTEST still finds it. Change appearance level to 1. Application tool. ZAPTEST shows me new object position right here. So it finds the first login text with the object because of the changed appearance order. Set it back to 2. Expect it to find back inside the login button. So this is how appearance works. Text color and gamma related to calibration of text color. I will talk about these properties a little bit later. Show you, give you example of the next one, characters. Allowed characters property serves as additional filter in object recognition. So we can set number of characters which must be part of the text of the object. Again, we're still talking about OCR type objects, which ZAPTEST will use in object identification. To show you an example, I have this notepad with a few text on this. Let me scan it. Okay, among others, I have object with text book. Okay, let me change it precision to high. Use enter some values in its characters property. So type be OK. Check if ZAPTEST can subject. So it finds it, I can check its precision, so it finds it with the precision. If I change the set of characters in the allowed characters, say BAK, and try to find the object, map, ZAPTEST tells me that it cannot find the object. So this is how the filter works. If I use KOB example, there are still same characters that makes that text of the object. ZAPTEST again finds this object without any. You can use letters, you can use numbers, you can use combination of letters and numbers, or you can also use special characters for defining the characters filter. Okay, next property in our list is scalability. Scalability applies only to relative objects. In my first scan, told you this. I have at least two relative objects that ZAPTEST automatically assigns for edit fields. And scalability will define how ZAPTEST adjusts size and position of a relative object based on changing resolution or object size. How this works, it's better to demonstrate using my scan. I'm going to add new object. This view, let's call it, for example, you see these lines on my notepad, which will show us as indicator for the object. So I added this object and I made it relative. Book. This one. For the method, I will use highlight. So at runtime, ZAPTEST highlights this object on the application under test like this. For this object, my edit object, since it's a relative object, scalability will take effect. And if I expand the list of items in scalability, you see that we have none, location, and size, and parent size. From all this, most useful will be parent size because it allows ZAPTEST to recalculate size and position of a relative object based on the changed size of the parent object. This is the name of the item says parent size. How this works, let's say I have view on a notepad, zoom in. Let's test again. See that beside the fact that size of my manager edit field has changed, ZAPTEST correctly identifies it because it recalculates its size and position based on the on its parent object, book object. What if I set its scalability to none? So no calculation will be done by ZAPTEST. And let's test again. You see that position for the relative object is the same it was when I added it to the GUI map. So ZAPTEST does not dynamically change its position and value. Set it to default. Okay, let's look at other options. Here we have location and location and size. These two will be based on the size of the application under test. To demonstrate what I'm gonna change, simply change size of my node window. So this time when I run test, ZAPTEST changes the position of a relative object based on the changed size of the application under test window. And if I select my scalability to location and size, ZAPTEST now changes both position and size of the relative object. When I increase the size of my modified application, ZAPTEST respectively recalculates relative object position. So this is scalability. Okay, next thing in our list of properties is recognition type. Recognition type defines how ZAPTEST recognizes the object. When you scan your application under test, you will see either OCR single or image. So these are two recognition types that ZAPTEST uses by default. Unless you use special scanning modes like multi-line or block. In this case, you will see multi-line objects or block-based objects. For partial recognition, you have to set it manually. When we use partial recognition, my first view, the example, you see that after my scan, I have object, welcome guest, register new user appears as a single object. So all the text, because it link text stays too close to the welcome guest, so ZAPTEST identifies it as a single object. What if in my test I need to click the register new user? If I use this object, then it likely will misfire because ZAPTEST will click in the middle of the object, which might be off the link itself. What I can do to fix this, I can use same object, or I can define new object simply by changing its name. Text property, which includes just the link text, register new user. And now we'll change recognition type to OCR partial. That means that ZAPTEST will use part of the visible text to define object. If I use my selection tool, you can see ZAPTEST shows me correct location and size of the object according to the properties recognition type, OCR partial, and text that I specified in its text property. Another good example is, again, remember me. If I want remember me to exclude checkbox from the object definition, same thing, just change it, recognition type from single to partial. If I need to operate with the checkbox, I would define a new object without worrying that ZAPTEST will capture checkbox when it's checked or unchecked and make it part of the object. Alright, so this is partial recognition type. Recognition type image. Images in ZAPTEST, it's a second object recognition principle that ZAPTEST utilizes. Can work with images when you cannot use text. Objects may or may not have text inside, so ZAPTEST identify object using OCR principle. In this case, you can define object as image. ZAPTEST may add images automatically during scanning. Here, I have here. Login button appears as image. Login text inside the button, it's a different object. Or you can define object images manually. For this, what I need to do, some good example. Standard procedure, press this button to define new object, give it a name. Get gamma. You have to manually set object size position. then I have to manually switch the recognition type to image. ZAPTEST changes precision to high because this is a desired level of precision for object. In some cases, you may find necessary to set custom precision to higher than high level. You can use 95 up to 100%. So this is how we define object manually. ZAPTEST will remember this object from the GUI map, and it will try to find this object at runtime. Objects in ZAPTEST, image objects in ZAPTEST are scalable. So that means that if you run your test on a different resolution, screen on a different resolution, and the object size changes, ZAPTEST will find it. For instance, with my object, login image, highlight. So when I run ZAPTEST correctly highlights the login button. If I zoom the view, size of the login image has changed. When I run this test, ZAPTEST is still able to find the image with the login correctly. Okay, another recognition type that we have left is coordinates. With coordinates, you can define object which will be purely defined by coordinates on the GUI. From the top left corner, you can set number of pixels for the object for its x and y coordinates. You can also set its width, height in pixels also. Why we use the coordinates object? With this type of object, ZAPTEST does not spend any time on object recognition, so it accesses those objects instantaneously. This is a good thing if you need to make your test run faster. You can define objects as coordinates. ZAPTEST allows you to dynamically assign object position from real objects. And at runtime you can save a certain amount of seconds from the execution. To demonstrate this principle, I can use my scan with subjects. ZAPTEST will not assign coordinate object automatically. It has to be created or changed in a manual way. So for my file object on this scan, I can select coordinates. What's relevant here is just the coordinates as I told you. So x, y, width, and height. I can do the same for the edit object. Click method with each of these three objects. Let's test. And you see that the click event occurs in a quick succession. It's because I have coordinate-based object. ZAPTEST only finds book object, which I use to make a focus on the application window, and then it just clicks all these three links very quickly. So this is the use for coordinate type object. And we can move to our next, which is, let me see, text language. Text language tells for itself, can select language for the which will be used with OCR type objects. ZAPTEST supports large number of different languages. It helps ZAPTEST to correctly identify object because it will retrieve it from the corresponding vocabulary. This property is useful when you need to test multilingual pages. You can define different objects using different languages. You can set it per object, set this property per object, or you can change it globally in test settings. I mean, in test options. If you go to the options, select sorry. This is where I can change default language. Another good use for this property is testing or using the same test to test applications on different languages. For this purpose, you can parameterize two things for each object. It's text language and text itself. And once we have set of parameters, both parameters for text and language, you can run it and verify with the same test. Okay, next property in our list is relative object. Relative object, it's just a button with the name. If I select my relative object, you can see that relative object button includes the name of the parent object. This button can be used to set a relative object. For instance, I can use object relative to the remember me. It's the button. Find and click on desired parent object either in a GUI map or Repository Explorer. It doesn't matter, ZAPTEST will. Okay, now my relative object button shows me the name of the parent object. If I need to reset relationship, I just need to click on this button twice. Yes, to confirm. So this object is no longer relative. Okay, next property in is Zoe Scan Mode. If I expand the items for this property, you can see we have inherit, outer, continuous, fragmented. Basically, there are two different scan modes that ZAPTEST utilizes, continuous or fragmented. Continuous means that ZAPTEST takes the application under test window and scans it in as a whole, as an entire window. Sometimes it doesn't work very well. So beside the continuous scanning mode, we implemented fragmented scanning mode. What happens with fragmented? ZAPTEST breaks the application under test window in virtual pieces based on the content. If we have more text than fragments that test will made out of it, then it scans fragments separately. So this may improve object recognition in certain cases. ZAPTEST will by default decide by itself which scanning mode produces better results. This is why we have auto selection, which is default, and also we have inherit item. Inherit means that for these objects, ZAPTEST will inherit this this property value from the upper level object. Upper level object for this object is view. View has its own scan mode, and it's also inherited. That means that the view will inherit it from the upper level object, which is application. Application in turn has this value inherit. That means that it will take it from ZAPTEST options. If I go to the Zoe section, I can see that Zoe scan mode set default to auto scan mode. This means that ZAPTEST will try both scan modes, continuous and fragmented, and decide for itself which works the best. If I need to change this, I can select desired scan mode. If I scan my another test window, I see that certain objects appear differently. For example, auto and tutorial now joined together as a single object, which is apparently not good to me. So for my case, my type of application, scanning mode does not work very well. So what I would do, back and change it to continuous. Let ZAPTEST decide which best. All right, next property that I'll talk about is Zoe recognition mode. If I look at the items here, we have default, auto, and 1, 2, 3-way detector. Logic behind this property is basically the amount of processing that ZAPTEST applies to object recognition. Remember that OCR type objects use dictionary or vocabulary to correctly find object that should make sense from the English language perspective. So this is why ZAPTEST may apply additional processing power to figure out what the correct text for the object. Again, auto is the default, or default is the auto. It means that ZAPTEST will decide itself which of the 3 ways works the best. To show you an example, get to my that I have here, I think already scanned right here. The toolbox object, I have it with 2 zeros, so it's a T00LBOX. When I scan it, ZAPTEST recognizes my zeros as O's. You see that in text property it says TOOLBOX. If I run precision tool, it tells me that it finds us with 100%. So for ZAPTEST, it's a perfect word toolbox with O's. Now, what if I need to get text out of this object? It's relative real quick. Script out. Get text. Set true optional arguments, so I don't need to worry about setting the object. Okay, and let's see output in the message box. See that getText still gets the box with alls. This is not what I need. Okay, so I need to get its text exactly as it appears on the text. What I can do for this object, go and change recognition mode. So I change it to one-way detector. One-way detector means that ZAPTEST performs a simple scan without applying any further processing power. So it will show me text as is. So let's run this again. Okay, now I got my toolbox text zeros. Okay, so this is how this property works. Okay, OCR templates. OCR templates, I will describe it together with text color. Text color related objects, properties are text color, gamma, and tolerance. To demonstrate, let me perform a scan. Bottom of our home page or login page, we have a number of links. When I scan it using standard approach, usually getting something like this. Okay, this is the partner links and sitemap links, and those captured by ZAPTEST as images. There is some OCR parts, but this is definitely not what I expect to get. It happens because color is pretty dimmed of the text. Also, there's dark background. ZAPTEST simply has a hard time to this text. And this is where we can use the calibration of the text color. All right, let's say for this object, which is Apple link, let me change it from image to OCR. So I need to use change recognition type to OCR. I need to include text. If I Precision tool, ZAPTEST will tell me that it cannot find this object, which is expected. Now I can update its color properties. To change color, I can go to this dialog where I can manually set color attributes, or I can simply pick the color from the GUI map. For this, I'm going to use this color picker tool. When I click it, my mouse pointer turns to the color picker. I can zoom in, and I can pick some good from this. Beside the color, we have color tolerance and gamma. If I move the sliders, ZAPTEST will show me how this settings applies to the letters. So using these sliders, I can make sure that ZAPTEST identifies object in a good trust, like this. Okay, now if I run the application tool, ZAPTEST finds the object, check its precision. Precision is perfect, so ZAPTEST gets it correctly. So this is one object. What if I need to do the same for other objects? Of course, I can read values that I have in the text color, in color tolerance, gamma applied to others. To make this process easier, we introduce templates. When I have this object selected, I can press this button to invoke templates dialog, and I can create the template based on the properties that I have. So ZAPTEST leads the property values that apply to this template. Okay, I have one template. If I need to apply the template to other object, let's say I can do the same thing. First I need to change it type, called text. template. If I use location tool, it finds the object, it shows me its precision, which is good. All right, now I have two objects. When you have template defined, you can do more with that. You can use the template during the scanning. If I rescan the same page, the template, I can select this option during the scanning. As a result, I have all my links appear as OCR objects with correct text recognition percentage. So this is how you can use text colors and also the templates. Okay, last thing that I wanted to mention is the application object itself. First of all, the view does not have any object recognition properties. View serves as a collection of other objects, usually representing a page or part of the page of the application under test. For application itself, there are two main properties that ZAPTEST uses to identify application, class and title. Title, usually visible title of the application, it's maybe title of the browser or title of the document that you have opened. Class, it's more internal. It shows class of the window from the Windows perspective. Other properties here, important properties are detection type. You can select flexible, exact match, or regular expression. With regular expression, you can define regular expressions for either class and title. Exact match implies that values for class and title should exactly match. You can use part of the text. And flexible means that ZAPTEST will attempt to modify these values in order to find the object. Usually flexible is a bit slower because it's additional processing power from ZAPTEST. If you want to run your test faster, it makes sense to change this detection type to exact match and make sure that the values matches the application under test. It's perfectly fine if you use only one property. You can remove the class, for example, and use only title. In the title, you can remove part of it. Let's say I want to get rid of the. So I can do like this. ZAPTEST will still be able to identify this object using exact match. All right. Let's move on to our Q&A session. Please submit your questions using the chat. Let me see what we have here. Okay, I got one question. I have many objects with same text but different color. Will appearance order work for all of them? The quick question is yes. Keep in mind that, my first view, pick one of the objects. Default color that ZAPTEST uses for object recognition is black. So any object that you select in the GUI map after scanning will show you RGB 000, which means black color. Black doesn't mean that ZAPTEST capture only black text of the object. It's universal color. It works with different colors too. So ZAPTEST will add objects with different colors to your object list. It will apply appearance, like you see with my login button. But In case when ZAPTEST cannot find object which is poses some difficulties, like in my with the partner links, for this object you will need to update its properties, and then you can include it in order of appearance or make it totally different. Okay, I have question. Why there are negative coordinates sometimes? Okay, it's a very good question. Yeah, I know what you mean. All right, yeah, show you an example. You can see negative coordinates with relative objects, because a relative object shows a set of coordinates. First of all, any object will show you coordinates. But relative object shows set of coordinates in respect to its parent. So in my example, I have y, which appears negative. That means that if I look at my object, its y position appears higher than parent object. So this is why the y coordinate is negative for this object. If I change this object position to say this one, now I have both x and y negative, because top left corner of the object in respect to the top left corner of the parent object appears which y coordinate, and left third which is x coordinate, so both are now negative. Okay, looks like we are top of the hour, a few minutes late, and let me this webinar. Please keep using ZAPTEST. Provide your feedback. If you have any questions, please submit our questions on our forum. Thank you very much for joining. Have a good day.